In this video, we're going to be talking about the central limit theorem and then solving a probability problem using the central limit theorem. Our strict definition says draw random samples of size n from any large population with mean mu and a standard deviation of sigma. The distribution of sample means approaches a normal distribution with a mean of mu and a standard deviation of sigma divided by the square root of n as n grows in size. Now, for most probability problems, we need to know that the distribution is normal. So when is n big enough for the distribution to be normal? In practical terms, we say when n is greater than 30. So we're going to draw random samples of size n greater than or equal to 30 from any large population mean, mu, and a standard deviation sigma. The distribution of sample means closely approximates the normal curve with a mean of mu and a standard deviation of sigma divided by the square root of n. Now I'm going to show you a visual of this and show you a visual of why we say any large population. It doesn't matter what the original population looks like. It can be normal, uniform, skewed, or this parabolic weird thing. If n is just equal to 2, our sample size is 2, it's gonna kind of match, not be normal. So kind of match in this case, kind of match in this case, but definitely not normal. As n is equal to 5, it's a little better, but look, not quite. But once n hits 30, we have a pretty normal curve. So it doesn't matter what the starting population distribution looks like. The distribution of the sample means is going to be normal if n is equal to or greater than 30. So on to our problem. A pharmaceutical company claims that the average reduction in seizures for patients using its drug is 6 per month, with a standard deviation of 3 seizures per month. So let's stop there and put down our information. For our population, we have a mean of 6 and a standard deviation of 3.3. Okay, now I'll keep reading. Medical researchers gather a sample of 36 patients taking the drug. The researchers find an average reduction of 4.6 seizures per month. How improbable is the sample mean in this company if this company's claim is true? So we've now taken a sample and we need to know what the distribution looks like for our samples and means. Well, our sample mean distribution, we know has an n of 36, which, hey, it's greater than 30. So we now know that it's normal, and it's going to have a mean of mu of 6, and it's going to have a standard deviation of 3.3 divided by the square root of n, which is 36. And that's going to equal 0.55. So we know that we have a normal curve with a mean of 6 and a standard deviation of 0.55. Well, if we want to find the probability of a normal curve, we need to use our online calculators. For that, I'm going to go to David Lane's calculator. So we're going to type in our mean, which was 6, and our standard deviation, which was 0.55, and they got a reduction in seizures was 4.6. We're going to find the probability that they get 4.6 or below. Well, the probability that's happening is 0.0055, so not even 1%. It's really improbable that the sample would have an outcome of 4.6 or less seizures.